In this video, we're going to talk about midsegments and triangles and learn about some of their theorems. Before we look at their theorems, let's make sure we understand what a midsegment is of a triangle. So a midsegment of a triangle is a segment that is going to connect the midpoints of two sides of that triangle. So moving into the theorem here, we have if a segment joins the midpoints of two sides of a triangle, then that segment is going to be parallel to the third side, and it's half its length. One way to prove the midsegment theorem is to use similar triangles. Another way is to use coordinate geometry and algebra. This style of proof is called a coordinate proof. So it won't look like our normal flow proof process. We are going to use our distance formula, midpoint formula, slope, all of those to prove this theorem. So we are given triangle TRI, where point T is going to be at 0, 0, my origin. Okay, so I'm going to label that. Then we have R is 6, 10, so right 6, and then up 10. Okay, so it's going to be right here. And then lastly, point I is going to be 8, 0, so we're going to go just 8 to the right and plot that point. So they're telling me that D is the midpoint of TR and that F is going to be the midpoint of TI. So real quick, I'm going to just pause this video and I'm going to draw my lines to create my triangle. All right, so now that I've done that, I'm going to go ahead and I'm going to start off by finding the midpoint of my segment TR so we can figure out where that point is going to lie. So I'm going to use my midpoint formula. I'm going to scroll on over here. TR. Okay, so remember that's going to be us adding our x's and dividing by 2. And then adding our y's and dividing by 2. Okay, so now that I've plugged into my midpoint formula, I can see 0 plus 6 is going to give me 6. And when I divide that by 2, I'm going to get 3. Then 0 plus 10 gives me 10. 10 divided by 2 will give me 5. So my midpoint for that point D, that point, the coordinates, is going to be 3, 5. So I'm going to come over here and we're going to plot that point, going 3 to the right and then up 5. Okay, my lines were just slightly off, so that's why. That's going to be point D. Then let's come back over here and find our point F. Oops. Okay, so I'm going to take my 0 plus 8, my x coordinates divided by 2. Then my y coordinates 0 plus 0 divided by 2. Okay, and when I solve that, I'm going to get that 8 divided by 2 gives me 4, and that 0 divided by 2 is going to give me 0. So I'm going to plot my point F over here at 4, 0. Okay, and then I'm going to just draw a line connecting them so I can see my midsegment. All right, so now that we have our points, okay, we are going to look and see. They want me to verify that DF is parallel to RI and that DF is half the length of RI. So let's start off by proving that this is going to be parallel. So to do that, we just need to find our slope. df, and then I'll find the slope of, we've got ri. Okay, so df, those were the midpoints. Those are the points up here that I just found. So to find that slope, I'm going to do 0 minus 5, and then 4 minus 3. So the difference of my y's divided by the difference of my x's. And I'm going to get negative 5 over 1, which will just simplify to a negative 5 slope. Then let's check that RI. So RI, we've got the difference in my y's is that 0 minus 10. And then the difference in my x's is going to be that 8 minus 6. So we're going to get negative 10 in the numerator, and then we'll get 2 in the denominator, which will simplify once again down to negative 5. So we have proven that DF and RI are going to be parallel. And now let's determine if DF is going to be half the length of RI. So to do that, we are going to use our distance formula. Okay, I'm going to start off by finding the distance of DF. Okay, so I'm going to take the square root of the difference of, I'll do my x's here first, my first parentheses, so 4 minus 3 squared, plus the difference in my y's squared, so 0 minus 5 squared. And just going through and simplifying, we've got that 4 minus 3 will give me that 1 squared, plus 0 minus 5 is going to give me that negative 5 squared. And when I square those, I'll get 1 plus 25, which will give me the square root of 26. Okay, that square root of 26 cannot be simplified because of the fact that my factors for that are just going to be 2 and 13. So I'm going to go ahead and move on since that is my final answer there. And I'm going to find the distance of RI. Okay, so I'm going to do the same thing. Take the square root of the difference of my x's. So for RI, that's going to be 8 minus 6 squared plus, and then I will have that 0 minus 10 squared. So 8 minus 6 will give me 2 plus, then I will have that negative 10 squared. And when you square those numbers, you're going to get 4 plus 100, which will just give me the square root of 104. So I need to see if I can break this down any. So I'm going to see here that I can break it down into 52 and 2. And then I'll get that 26 and 2, which this will give me a pair. So I'll pull that out. And then I'll be left with that 26, square root of 26. So we have now proven that DF is going to equal to 1/2 of RI, because if you notice here, if you take this distance and you divide by 2, that just cancels out with this 2 here, and you will be left with that square root of 26 that we got for DF. All right, now let's actually move into some solving, okay, applying those theorems. So in number 1, we have that M, N, and P are midpoints. Okay, so I'm going to mark it, just it's congruent on each side. And that MP is going to be 22. Okay, and then we have that MN is going to be 24. And that the perimeter of this triangle here, this inside one triangle, MNP, is going to be 16. So I want to find NP and YZ. Well, to find NP, I'm going to take my 22 plus 24, the lengths I do know, plus that NP, and set it equal to the 60 because perimeter is just adding up all my sides. Then I'm going to just solve for that NP. So here I'm going to get 46 plus NP equals 60. Therefore, when I subtract, I'll get that NP is going to be 14. Okay, so that's one part of what I was asked for. Now I need to find that YZ. So I'm going to write that we're going to find YZ, but let's look and see what YZ actually is. So YZ here is this length, which if I look, okay, I will see that it's going to be parallel to this MP because it's that midpoint. These are creating my mid segments. And so I can just double that. So 2 times that 22 is going to give me 44. So YZ is 44. Okay, so moving into number 2. So in number 2, we're asked to find the measure of angle AMN. So I'm going to highlight that real quick. So AM in this angle here. And the angle, I'm going to do this in a different color, ANM. Okay, so we're trying to find these two angles here. Well, right off the bat, I'm going to see, I notice that since these two segments on either side of these points M and N are congruent, we know that it's a mid-segment and it's going to be parallel to this side CB. And so what's helpful there is the fact that they are parallel lines, and we can use parallel lines cut by transversal. So we will get that these two angles here, the 75 degrees and this angle AMN, are going to be congruent because they are corresponding angles. So the measure of angle AMN is going to be 75 degrees. And since I noticed that triangle ANM, that whole triangle, that small one right there, is going to be an isosceles triangle, I can say that this angle over here, which is that angle ANM that they wanted, is also 75 degrees. Okay, so moving into number 3. In number 3, we are told the perimeter of a triangle is 78 feet. Find the perimeter of a triangle formed by its midpoints. Okay, so for this, I'm going to just draw a quick visual of a triangle. Okay, and so for this triangle here, I'm going to let my sides be X, Y, and Z. Okay, and so I know here that X plus Y plus Z, all the sides of the triangle, should add up to that perimeter, that 78 feet. And we are trying to figure out what the perimeter of the triangle will be when it's formed from the midpoints of those. So here, if we draw that, okay, we know that these are all congruent on either side. And so what I can say is that since these mid segments will then be just half of those side lengths, right? I can take this entire thing and I can multiply it by 1/2, and that will give me that 1/2 of X, 1/2 of Y, plus 1/2 of that Z, and that will be equal to 39. Okay, so what I'm seeing here is that 1/2 of X plus 1/2 of Y plus 1/2 of Z should be 39. Therefore, my perimeter being formed by the midpoints should be 39 feet. Okay, moving into number 4. In number 4, they say only one of the lengths, A, B, or C, can be found. Okay, so let's start off there. Which length can be found? Well, if I look here, I notice that 4 is congruent to 4. Over here, I notice that 3 is congruent to 3. But when I look at this point here, on either side, we have different lengths. We have 5 and we have 6. Therefore, this point is not a midpoint. And therefore, any segment created from this point is not going to be a mid-segment. So the only one that will work is going to be that B. So we're naming the segment, so segment B, and we want to find its length. Okay, so to find the length, we're going to say that 5 plus 6, so the side parallel, divided by 2, because it's a mid-segment, which this will give me just going to be that 11 over 2. And so we can say that B is equal to 11 halves, or if you want to write it as a decimal, you can say 5.5. Okay, moving into our last and final problem, number 5. We got given that DE is x plus 5, so I'm going to label my picture. And BC is 3x minus 1. I want to find x. Well, before I do that, I need to take note that on either side of these points, D and E, it is congruent. So we do have a mid-segment. So that means that this line DE is going to be parallel to BC, and it should be half of BC. Well, instead of taking half of that, we've got 3x minus 1 and setting it equal to my x plus 5. I'm going to actually just double my mid-segment. I'm going to say 2 times that x plus 5 will be equal to 3x minus 1. This is the one I'm going to use to solve just so that I don't have to deal with decimals or fractions because of that 1/2 and the fact that I have those odd numbers. So we're going to stick with this one, and I'm going to just go ahead and use this to solve. So I'm going to get 2x plus 10 equals to 3x minus 1. I'm going to subtract my 2x to get x minus 1, and then I'll add that 1 over to get x is going to be equal to 11. And there you have it.